Welcome to the DIY Honda Garage channel. DTC P16F3 indicates a low voltage issue in the starter cut Relay 1 control circuit, affecting the engine's ability to start properly. This DTC often points to electrical issues within the circuit that controls the starter cut relay, which is crucial for the engine's ignition process. The starter cut relay is responsible for allowing current to flow from the battery to the starter motor, initiating the starting procedure when conditions are right. Potential frustrations can arise from this issue, as a vehicle may fail to start or exhibit intermittent starting problems. Effective troubleshooting is essential to pinpoint the exact cause of the low voltage, which may stem from the relay itself, the powertrain control module, PCM, wiring issues, or other electrical faults. Understanding the components involved, their functions, and their location in the vehicle will facilitate a more effective diagnostic approach. The starter cut relay is a critical component found in the engine compartment that ensures the starter motor receives the necessary voltage to initiate engine operation. The powertrain control module, PCM, acts as the brain of the vehicle's electrical system, managing the functions of the engine and its related components. It processes input from various sensors and sends output signals to components like the starter cut relay to control engine starting. The relay circuit board aids in connecting the starter cut relay to the rest of the vehicle's electrical system. Additionally, wiring connecting these components plays a significant role in the overall function. If any wire is damaged or has a poor connection, low voltage issues like those described by DTC P16F3 can occur. Spotting the physical location of each component is vital for a thorough investigation, allowing for an efficient troubleshooting process. A low voltage issue in the starter cut relay circuit could arise from several causes. Loose or poor electrical connections can impair the flow of voltage, preventing the starter from operating correctly. This can occur at terminals or connectors involved in the power distribution to the starter cut relay and PCM. Additionally, shorted wiring may create unintended circuits or pathways that disrupt normal operation. If a wire is damaged, it may cause the signal to weaken significantly. Other potential failures include a malfunctioning powertrain control module, which, when faulty, may fail to send a proper signal to the starter cut relay. Furthermore, a damaged relay circuit board can also lead to similar DTC codes and issues with starting the engine, highlighting the need for thorough diagnostics. Thus, understanding these causes is essential to target the right area during troubleshooting. The symptoms associated with DTC P16F3 manifest primarily when the engine fails to start due to low voltage in the starter cut relay circuit. Owners may initially notice that the engine does not crank when ignition is attempted, which can lead to frustration and confusion. Some may experience intermittent starting issues, where the vehicle starts on occasion, but fails to do so at other times, making it unpredictable and unreliable. Furthermore, the error code would typically be displayed in the vehicle's diagnostic system, prompting an investigation. In some cases, other electrical system malfunctions may accompany these symptoms, as the low voltage condition can influence various components integrated within the vehicle's electrical framework. Recognizing these symptoms is crucial for a timely and effective repair. The first step in troubleshooting DTC P16F3 is to attempt to start the engine. This is crucial as it establishes a baseline for subsequent diagnostics. If the engine starts successfully, this indicates that there may not be an immediate issue related to the starter cut relay, and troubleshooting can proceed to the next steps. Conversely, If the engine does not start, this could confirm that there is a problem with the voltage reaching the relay or the relay's functionality itself. Following this confirmation, one can progress to further investigation, which is vital to isolating the problem. Understanding the importance of the initial engine starting check allows technicians to efficiently navigate through the troubleshooting process. In this step, the technician should turn the vehicle's ignition to the off-lock mode, followed by turning it to the on mode. This action is imperative to reset the vehicle's onboard diagnostic system. Using the HDS, or Honda Diagnostic System, the technician should clear the DTC. Once cleared, checking for any pending or confirmed DTCs can reveal the current state of the vehicle's systems. The reason for this clearing process is to determine whether the error is persistent or intermittent. If DTC P16F3 is still indicated, it indicates a confirmed failure in the circuit, ensuring that the technician can focus their attention on the components causing the issue. This methodical approach helps narrow down the possibilities while maintaining a comprehensive diagnostic strategy. At this stage, the technician is to check for a shorted wire within the starter cut relay circuit. First, the vehicle should be switched to the off-lock mode. Using the HDS, the technician must jump the SCS line, waiting for more than 1 minute to ensure any temporary issues are resolved. With the relevant connectors disconnected, the technician will test for continuity between defined test points to verify the integrity of the wire. In this diagnostic procedure, the technician will be looking specifically at the connection between the PCM and the relay circuit board. If there is continuity, the wire may be shorted, necessitating an inspection for any visible damage or faulty splices. If continuity does not exist, this suggests that the wire is in good condition for this testing and other issues may need addressing, ensuring thorough execution of this troubleshooting step. In this step, the technician isolates the powertrain control module, PCM, as a potential source of the issue. By again placing the vehicle in the off-lock mode, the technician will jump the SCS line with the HDS and disconnect the relevant PCM connector. After ensuring that the vehicle is ready, the technician turns the key to the on mode, allowing for voltage measurement between two test points. It is essential to verify if battery voltage is present at the designated test points. A positive result indicates that power is reaching the PCM, which means any faults might lie in the PCM itself or in the circuit leading to the starter cut relay. If there is no battery voltage detected, however, further investigations must focus on wiring integrity and possible open circuits. This meticulous voltage assessment is a crucial juncture in identifying the root cause of the DTC. Next, the technician will conduct an open wire check for the starter cut relay circuit. Following the standard procedure, the vehicle should be in off-lock mode and the necessary connectors disconnected. Here, the technician will check the continuity between the relay circuit board and the PCM to ensure that the wire path is intact and unobstructed. If continuity is confirmed, this suggests that the wiring is functioning properly. Should continuity fail, however, it indicates an open in the circuit, prompting immediate investigation and repair of the wiring between the components. Ensuring the integrity of the wiring is essential for reliable voltage delivery, making this step crucial in the overall troubleshooting process. A detailed examination of all connections and terminals should be performed to identify any potential issues. In this step, the technician checks the status of fuse number A43, which is integral to the starter cut relay circuit. The importance of this fuse lies in its role in protecting the circuit from short circuits and overloads. If the fuse is intact and operational, the technician can proceed to the next troubleshooting step. Conversely, should the fuse show signs of damage or disconnection, it will need to be replaced immediately. Additionally, it is critical to check for shorts or faults in the wiring leading from the fuse to the relay circuit board, which may have caused the fuse to blow. Identifying any underlying issues ensures that future fuses will maintain their integrity. Therefore, a thorough inspection is necessary to guarantee the system functions properly after repairs. The final troubleshooting step involves another open wire check, this time focusing on the IG1 starter cut wire. The technician should measure for voltage between the specified test points while the vehicle is in the on mode. This provides insight into whether battery voltage is reaching the appropriate components in the circuit. If voltage is confirmed, it indicates that the wiring is in good shape, and issues may stem from the relay circuit board itself. Therefore, if everything else checks out, the technician may need to replace the relay circuit board to resolve the DTC P16F3 issue. However, if no battery voltage is present, this would indicate an additional fault, likely requiring wiring repairs between the fuse and the relay circuit board. By following this step meticulously, the technician ensures a comprehensive understanding of the problem, paving the way for successful resolution. Upon completing all troubleshooting steps, it is essential to verify that all repairs and inspections have been executed correctly. This includes ensuring that every electrical connection is secure and free of corrosion, as well as reassembling any components that were disconnected during the diagnostic process. The next step is to retest the engine starting function to confirm the effectiveness of the repairs. Successful startup will indicate that the issue has been resolved and the vehicle is in working order. If the engine fails to start, it may require revisiting previous steps to confirm that all possible issues have been appropriately addressed. Final repair verification ensures that the fix is thorough and that no recurring issues will arise in the starter cut relay circuit. Preventive maintenance is an invaluable approach to mitigate potential issues encountered with DTC P16F3. Regular inspections of wiring connected to the starter cut relay circuit can help catch early signs of wear, damage, or corrosion that can lead to future failures. In addition, periodic checks of fuses, especially the A43 fuse at risk of issues, can prevent unforeseen breakdowns or operational hiccups. Ensuring the integrity of the starter cut relay and related components through regular maintenance can help extend the lifespan of the electrical system. By making these checks a routine practice, vehicle owners can improve reliability and performance while reducing instances of unexpected failures. These proactive measures emphasize the importance of consistent vehicle care in maintaining optimal function. In summary, DTC P16F3 signifies a low voltage condition in the starter cut relay 1 control circuit, often leading to the engine failing to start. The diagnosis reveals important components such as the starter cut relay and the powertrain control module, PCM, that are central to the issue. A systematic approach to troubleshooting is essential, starting from simple checks of the engine's operational state to more complex investigations of wiring, voltage, and component failures. Following the outlined troubleshooting steps will help facilitate a successful diagnosis and repair. Additionally, understanding preventive maintenance practices contributes to long-term vehicle reliability. Ultimately, careful attention to these aspects can aid owners in maintaining their Honda Accord and avoiding potential starting issues in the future. Please like and subscribe to the channel. See you next time.